Before the engine, before the road, before the sail, humanity moved on foot, or not at all. The dugout canoe changed that first. Carved from a single log, it was the original vehicle. Silent, simple, and revolutionary. Then came the ox-drawn sledge, and eventually the wheel, invented in Mesopotamia around 3500 BCE, perhaps the single most consequential idea in the history of human movement. Wind followed. The sail freed sailors from muscle and tide. The horse-drawn chariot defined warfare and status for 2,000 years. Egypt built galleys. Phoenicia built trade networks. Greece built triremes. Rome paved 80,000 kilometers of road and connected an empire. And along the Silk Road, camel caravans carried goods 4,000 kilometers between Rome and China, long before anyone imagined what would come next. The Middle Ages moved slowly, but a few inventions changed everything. The stirrup seems trivial, a simple iron loop, but it transformed cavalry warfare and reshaped the balance of power across civilizations. The Viking longship, shallow enough to raid rivers, crossed the Atlantic centuries before Columbus. The magnetic compass freed navigators from coastlines, and the caravel, nimble, lateen-rigged, became the key that unlocked the entire age of exploration. In 1492, Columbus crossed the Atlantic in 70 days. The world would never be the same. Spanish galleons carried silver from the Americas to Europe. Dutch fluits, mass-produced and efficient, powered a commercial empire. On land, the stagecoach offered the first scheduled passenger service, London to Edinburgh in 4 days. And beneath the Thames, a man named Cornelius Drebbel rode history's first navigable submarine. The Industrial Revolution didn't just change how things were made, it changed how everything moved. Britain built 4,000 miles of inland canals to carry coal and goods before anyone thought to put a steam engine on wheels. In 1769, Nicolas Canoes did exactly that. His steam-powered three-wheeler hit 4 kilometers per hour before crashing into a wall. Progress. In 1783, 400,000 Parisians watched the Montgolfier balloon rise into the sky, and for the first time in human history, people left the ground. The steamboat conquered rivers regardless of wind or current. The Draisine gave us the bicycle, and Stephenson's rocket, winning the Rainhill trials at 47 kilometers per hour, launched the entire age of rail. By 1830, the Liverpool to Manchester Railway carried nearly 500,000 passengers in its first year. Clipper ships crossed oceans. Propeller steamships crossed the Atlantic in 15 days. London opened the world's first underground railway in 1863. The Suez Canal cut 7,000 kilometers off the Europe to Asia route, and the Transcontinental Railroad connected the American coasts, turning a 6-month journey into 7 days. In 1885, 3 inventions arrived almost simultaneously that would define the next century. Carl Benz built the first gasoline automobile. John Kemp Starley built the modern chain-driven bicycle. And Gottlieb Daimler strapped an engine to a wooden frame and created the motorcycle. The internal combustion engine had arrived, and it wasn't letting go. Rudolf Diesel's engine, more efficient than steam, would go on to power over 90% of the world's shipping. Then came the airships, Zeppelin's massive rigid giants, floating passengers across the Atlantic. And then, on a cold December morning in 1903 at Kitty Hawk, Orville Wright flew 12 seconds and 37 meters. Humanity had conquered the air. The ocean liner RMS Lusitania crossed the Atlantic in 4 days. Henry Ford's Model T put the automobile within reach of ordinary people. 15 million sold, cities redesigned around roads. Blériot crossed the English Channel by air in 37 minutes. The Panama Canal cut 12,000 kilometers off shipping routes. Tanks rolled across the Western Front. Alcock and Brown crossed the Atlantic non-stop in 16.5 hours. Goddard launched the first liquid-fueled rocket. Lindbergh flew solo from New York to Paris in 33 hours. And Frank Whittle filed a patent for the jet engine, the device that would eventually make the entire world reachable in a single day. The decades between the wars and after them belonged to aviation. Pan American's flying boats bridged oceans before intercontinental airports existed, landing on lagoons, refueling in island ports. The Douglas DC-3 became the first aircraft that could profit on passengers alone, without mail subsidies keeping it airborne. Germany built the Autobahn. The Heinkel Hiwin-78 became the first jet-powered aircraft in history. Sikorsky's VS-300 helicopter changed rescue, combat, and logistics forever. The V-2 rocket, a weapon of terror, was also the first object ever to reach space. Chuck Yeager broke the sound barrier in the Bell X-1. The de Havilland Comet brought jet travel to passengers, and the USS Nautilus sailed beneath the Arctic ice, nuclear-powered, unstoppable. Meanwhile, a single standardized steel container reduced global shipping costs by 97%, quietly reshaping world trade. On October 4, 1957, a metal sphere the size of a beach ball began orbiting Earth, beeping. Sputnik changed everything. Within 4 years, Yuri Gagarin orbited the planet in 108 minutes, and humanity had left it. Japan launched the Shinkansen, reaching 210 kilometers per hour on opening day, and has never had a fatal crash. The Saturn V rocket, still the most powerful ever flown, sent humans to the moon. Concorde crossed the Atlantic in 3.5 hours. Apollo 11 landed on the surface of the moon in July 1969. The Boeing 747 jumbo jet made mass air travel affordable for hundreds of millions, and supertankers longer than 4 football fields reshaped global energy logistics. The Space Shuttle Columbia flew in 1981, the first reusable spacecraft in history, completing 135 missions over 30 years. France's TGV set a rail speed record of 574 kilometers per hour. GPS, 24 satellites orbiting 12,000 miles above Earth, began guiding every aircraft, ship, car, and eventually every smartphone on the planet. The Channel Tunnel finally connected Britain to continental Europe beneath 50 kilometers of sea. Toyota's Prius proved that hybrid technology could be commercially viable. The International Space Station, assembled by 16 nations over 13 years, became humanity's permanent outpost in orbit. Shanghai's maglev train reached 431 kilometers per hour in under 4 minutes. The Airbus A380 carried 800 passengers across 2 decks. Tesla's Roadster proved electric cars could be fast and desirable. SpaceX landed an orbital rocket and flew it again, cutting launch costs by over 90%. The 2010s and 2020s brought a wave of disruption that is still accelerating. Elon Musk published a white paper proposing vacuum tube pods traveling at 1,200 kilometers per hour, and a global engineering race began. Waymo's self-driving cars began logging millions of autonomous kilometers on public roads. Amazon delivered a package by drone for the first time. SpaceX's Crew Dragon restored American human spaceflight after a 9-year gap. Norway launched the world's first fully electric and autonomous container ship. NASA's Ingenuity helicopter flew on Mars, the first powered flight on another planet. Electric air taxis began certification flights over major cities. SpaceX unveiled Starship, the largest rocket ever built, designed to carry 100 humans to Mars. Hydrogen trains began carrying passengers across Europe, with nothing but water vapor leaving the exhaust. And solid-state battery technology began promising electric vehicles with a 1,000-kilometer range and 10-minute charging. The future was arriving faster than anyone had predicted. What comes next is almost impossible to comprehend. Autonomous truck convoys managed by artificial intelligence could reshape every supply chain on Earth. Hyperloop pods may connect cities at 1,200 kilometers per hour inside vacuum tubes. Suborbital spaceplanes could carry passengers between any two cities in under 90 minutes. A lunar space station will serve as the hub for permanent human presence beyond Earth. Starship fleets aim to carry the first settlers on the 7-month journey to Mars. A light sail the size of a chip could reach Alpha Centauri in 20 years. A space elevator built from carbon nanotubes could lift cargo to orbit for less than $1 per kilogram. And somewhere in the mathematics of theoretical physics, barely visible, probably impossible, perhaps not, lies the possibility of compressing space-time itself, from a dugout canoe to a warp drive. The journey continues,